friends at Atomos pushed forward and sponsored the 8th and last module in the Anamorphic Cookbook. This one, where we'll talk about anamorphic exclusive topics for post-production, starting with desqueezing the footage and setting your final aspect ratio. Next, I will address common issues and mistakes such as skewing and distortion, to then move on to some more circumstantial issues like anamorphic mumps and dealing with a changing squeeze factor like what we get from several Sure lenses and many double focus adapters. If you paid attention to Module 2, you would know this stems from synchro focus designs. Last, in Episode 4, we'll discuss live streaming and anamorphic as that poses a handful of technical challenges. We're just coming off of Module 7 with our on-set experience and footage, and now we have to finish the project. Yeah, I know we haven't done Module 7 yet, but you try getting sponsors so you can teach people on the internet for free, okay? I'm moving forward as best as we can. Not everything has to be in order. Anyway, coming off Module 7, as I was saying, with a project in the can and ready to push it through post-production, except what is the best path for it? Let's get started. Actually, before that, let's recap this important part of Unfilmed, Module 7, where we had a moment on set to discuss and decide our final aspect ratio. A lot of us default to deciding a project's aspect ratio by doing the math of sensor aspect ratio times anamorphic squeeze factor. Like if I'm using a 16:9 sensor and a 1.33 lens, my final aspect ratio must be 16 divided by 9 multiplied by 1.33 or 2.36 something to 1. Well, that's just lazy. Reality is not so much about what the lens gives you, but what is it that you want to deliver. A project's aspect ratio has a deep meaning and provides a good shortcut to set your audience's expectations about your project. So, not being purposeful about it is not the pro move right here. For example, right now I'm filming in 16:9 with 1.5 times lenses, and I decided in advance that my final aspect ratio would be 2.39 to 1. So after setting up the monitor to desqueeze the image, for which we have tons of options with Atomos, I also set up crop marks or frame guides so I know what's being captured, but it's actually out of the final framing. Back in the day, a lot of films had projection mats designed to do this, but on the theater, and getting a projection mat wrong could drastically affect your experience as a viewer, allowing you to see a boom microphone or even lights that were in the final recorded frame, but not in the final design frame. These days with digital, we hardly run into the same risk, but it's important for us to have that window on set so that we know what the frame is supposed to look like once we get to post-production. The other advantage that I get from using an external recorder, like the ones by Atomos, is that I get the option of beefier codecs, such as ProRes or even RAW recording over HDMI, which pulls in a lot more color information from the sensor than what the camera's internal processors can record. A wise choice of codecs will give you a smoother time in post-production, as well as more control over your final color. So don't default to what your camera gives you if your project requires more. Now it's time to get the footage and conform it to our decisions from earlier. I'm doing most of the examples for this module in Resolve 18, but you can translate most of the ideas to other software packages such as Adobe Premiere, After Effects, or Final Cut Pro. This is not a tutorial on editing or color correction, but with dealing with anamorphic footage in post-production. Let's jump in Resolve. I'll first import the footage and confirm that we have both a squeezed image and all that extra recorded area that is not meant to be used. Once we drop the squeezed images on the timeline, we can go to the inspector in any given clip and adjust the zoom value on the horizontal axis. You can unlink the horizontal and vertical zoom by clicking on the chain link icon and then just input the squeeze factor on the X value. This pushed a bunch of the recorded image outside the final frame, but we'll get to it. I've done a similar tutorial that covers this process in Premiere and Final Cut Pro, so you can watch that to make your life easier. There is an alternative to this step which I find much more elegant, so let's do that. Select and right-click all the anamorphic clips in the media pool. Then go to Clip Attributes and pick the squeeze factor from under the pixel aspect ratio dropdown. From here on out, the clips will look properly desqueezed both on the timeline and on the preview window. Resolve even offers you a custom option for unusual desqueeze values. Pixel aspect ratio is the digital counter to anamorphic lenses, sort of. It's been around since the early digital video days, and here's how it worked. Back in the 2000s, aka the Panasonic DVX100 era, only the most groundbreaking DV camera ever made, we were also transitioning from 4x3 TVs to 16:9 screens. Most cameras of that era could film and deliver content for both sizes of screens, but the container for the video was always NTSC standard 720 by 480 pixels. 720 by 480 has a 1.5:1 aspect ratio, so it's neither 4x3 nor 16:9. What's going on? From the DVX100's Wikipedia page, the original AG DVX100 can only shoot in a 4x3 aspect ratio. The A revision added a capability to shoot widescreen video, but this appeared squashed in the built-in monitor. The B revision introduced the ability to properly monitor 16:9 aspect ratio. Okay, we got some trickery going on since the output file is always the same size, 720 by 480 pixels. That is the pixel aspect ratio. When filming for 4x3, the camera would include the metadata for pixel aspect ratio of 0.9. This works the exact same way as our frames aspect ratio, but at the pixel level. It means that for every 1 pixel height, we'd squash the width to 0.9 instead of 1. This results in a display resolution of 720 pixels wide, squished with 0.9 pixel aspect ratio, giving us 648 pixels width and keeping the 480 pixels height. 648 by 480 is just 8 pixels wider than the 4x3 standard definition resolution of 640 by 480. So we figured out how the camera delivered 4x3 out of a 1.5:1 container thanks to the pixel aspect ratio. For widescreen, the pixel aspect ratio was 1.21, and that gave us a width of 720 times 1.21, or 872 pixels, by the height of 480. That is less than 20 pixels wider than the base 854 by 480 standard 16:9 footage. The metadata included in the recorded material would tell your editing software to squeeze or stretch the images according to those values, so you'd see the results properly in the edit and delivery. Once I drop the clips onto the timeline, many things look off. First, we have black bars on the top and the bottom of the frame. Second, we can see the full width of the frame and not just the area that we decided to use. Well, we never set up our timeline, so let's start there by using a calculator I made just for this. In the calculator, I'll input both my final frame width, 5160 pixels, and the aspect ratio of 2.39:1. My anamorphic squeeze is 1.5, and from the clip inspector, I can find the dimensions of the video file, 3840 by 2160. With all of that in, I'll hit calculate, get a bunch of numbers, and a rough preview of the discarded area of my captured image. Great. Back in Resolve, I'll right-click the timeline in the media pool and go to Timeline Settings. Here, I'll uncheck the Use Project Settings and use the timeline settings from the calculator. In here, it's essential that we confirm the timeline's pixel aspect ratio is set to square. Remember when we talked about pixel aspect ratio like a minute ago? Here you see remnants of that with the grayed out options for 16:9 anamorphic and 4:3 standard definition. If you set this to anything but square, you might see a properly desqueezed image in the edit. The problem comes when you export the video. So while in the editing bay you are looking at a properly desqueezed image, once you try and show it to your friends, you get a squeezed result. If you upload it to YouTube, you also get a squeezed result. This confuses a lot of people, so here's the all-time answer. just set it to square, always and forever. If you ever run into a scenario that requires anything different than square, I'm sure at that point you will also have the technical knowledge and support to navigate it. Now that we confirmed that our timeline's pixel aspect ratio is set to square, I really say that a lot, we can finally hit OK and see what we got. We still have the black bars on the top and the bottom of the frame, and we still see all that stuff that we don't intend to see on the sides of the frame. I could manually zoom in every clip on the project, but that's counterproductive. I know Resolve is making a decision to have them all fit the frame horizontally, so I'm going to change that setting so it fills the frame instead of fitting the frame. Back onto our timeline settings, we'll change mismatched resolution to scale full frame with crop. Once we hit OK, this rule will be applied to all clips that we drop into this timeline, solving our problem. If you want to deal with exceptions, you can change this behavior on a per clip basis by going in the inspector at the very bottom and changing scaling from project settings to whichever mode works best for your needs. Let me go back to the calculator for a little bit. For the less thoughtful software packages, the easiest way to make the footage fit on your timeline settings is to rescale the clips. It's all fun and games while you only have to use the horizontal zoom, but in order to preserve image resolution, you want to stick to a timeline that isn't much larger than your final delivery size. Okay, I think I lost you there. Let's backtrack. I'm sure you thought about this before, but anamorphic lenses don't give you free resolution. Filming a 4K clip with a 2x lens is not the same as filming an 8K clip. It's math and pixels. And as good as computers are with math, there are still losses if you do unnecessary rescaling. For example, let's say I filmed a short with the S5 II in open gate mode, recording 5952 by 3968 resolution, using a 2x lens. I'll bring this footage into Premiere, create a timeline that is 5952 times 2 pixels wide for the Desqueeze by 3968 pixels tall. Then I'll drop in the footage, go to the scale property, and set the width to 200. Cool, the footage looks correct and everything. But I'm not delivering in 12K. In fact, I'm delivering in DCI 4K, 4096 by 2160. So I'll create a new timeline with those settings and drop in my Desqueeze timeline in there. And again, go to the scale property and adjust it so it fits. What I've done so far is upscale the footage to then downscale the footage. That can't be good, and my computer will sure give me some hate for it in performance. That's why I made the calculator in the first place, so you can use those numbers in the scale property and get your perfect results. Continuing with our example, let's add the data to the calculator, including the numbers for our delivery format. The width of the frame is 4096, and the aspect ratio is 4096 divided by 2160, which rounds to 1.89 to 1. Now, in Premiere, I'll create a new timeline and use the settings I got from the calculator. I drop in the footage, everything looks off. That's all right. I'll go into the scale property and input the values we got from the calculator. And voila! No more 2 steps forward and 1 step back with resizing the image. We are good to edit here and see both the Desqueeze results as well as our correct final aspect ratio. I'll say this one last time. Always make sure the pixel aspect ratio of your timeline is set to square. There are very few displays out there that use a different setting, and if you're delivering content online, then you definitely want it to be square. This episode had a fair amount of numbers flying around. Post-production has some of that. All the artistic things we eyeballed on set now must be accurate. You don't want your audience looking at footage like this, or even worse, like this. And the only way to do so is to get the numbers right. We'll see some more numbers in the following episodes, but the main focus are the concepts instead of execution, and I bet you'll be able to follow. In the next one, we'll look at fixing common problems that come from filming with anamorphics, namely skewed images in varying degrees of intensity and distortion. Yeah, we all love anamorphics that give you barrel distortion, but I'll show you pincushion is not a problem, and sometimes might even be a cool thing. If you're lost on the sauce, This episode is part of the Anamorphic Cookbook, a very long series of tutorials focused on concepts rather than on specific pieces of gear, which takes you from the very origins of anamorphic lenses in Module 1 all the way to post-production where we are now in Module 8. Thank you so much for watching to the end, and I hope you can tolerate some more math in the coming videos. Stay tuned. Out.